All right, so we're going to graph f of x is equal to log base 2x. And the most important thing to do when graphing logarithms without a graphing calculator is choosing your x values wisely. So what we want to do is we want to look at the base. So in this case here we have base 2. And we want to make sure that our x value is a value that when we take log base 2 of that x value, we get a whole number answer. So 1 is always a good choice, because when we do log base 2, 1, 2 to the 0 power is 1. So that means our f of x would come out equal to 0. So on our graph, we would be at 1, 0. Okay, so another good value to use here, again looking at the base, is if we choose x equal 2, log base 2, 2 is equal to 1, another whole number value. So we can graph 2, 1. And then sticking with that base 2, 2 to the second power is 4. So if we use x equal 4, that means that log base 2 of 4 is equal to 2. So we have 1, 2, 3, 4, 2. We can see we have a vertical asymptote at x equals 0. So we would have our function. All right, let's try one where we have the base as a fraction. So we have f of x is equal to log base 1/3 x. Well, x equal 1 is still a good choice here, because log base 1/3 of 1, 1/3 to the 0 power has to equal 1, so f of x has to be 0. All right, now to get our next choices to create whole numbers as our answers for f of x, we want to look at the denominator. All right, and we want to pick powers of 3 as our x value. So for example, if we choose x equals 3, we would have log base 1/3 of 3, and 1/3 to what power equals 3, and it would be to the -1 power. So that means we would have 3 as our x, and then our f of x would be -1. We're going to stick with the theme of the powers of 3. So our next point I would choose would be log 1/3 of 9, because 1/3 raised to the -2 power is equal to 9. So that means that if 9 is our x, -2 is our output f of x. All right, so we go to graph this. We've got 1, 0. We've got 3, -1. And then we've got 9, -2. 1, 2, 3, 4, 5, 6, 7, 8, 9, -2. Okay, so now we're going to get our graph. Still has a x asymptote at x equals 0, but now it's a decreasing function. All right, in our next example, we have f of x is equal to log base 3 x plus 1 minus 2. So we have a shift in here. Okay, so in order to handle that, and if whatever, it doesn't matter what the expression is in there, we still want to use those values that work for base 3. So we want what's in the parentheses to equal 1 so that we can do log base 3 of 1. So the first thing we would do is we would set x plus 1 equal to 1. And then if you solve for x here, you would get x equals 0. All right, so 0 is going to be one of the values I choose for x. Okay. Along that same line, if we want to create a log base 3, because that's an easy value to do in our head, we would set x plus 1 equal to 3, and we would get x equal 2 when we solve for x. So 2 would be another value that we want to use. Another power of 3 is 9. So if we choose x plus 1 equal 9, and we solve for x, we get x equal 8. So because of that shift, what we're doing is we're moving each one of those values back 1. Okay, so we're going to do 0, 2, and 8. So what happens when we plug in 0? Well, we get log base 3 of 1, which is 0, minus 2, so f of x would be negative 2. When we plug in 2, we get log base 3, which is 1. 1 minus 2 is negative 1. When we plug in 8, we get log base 9, which is 2. 2 minus 2 is 0. So those are 3 points that we can use. So we have x equals 0. When x equals 0, we've got f of x is equal to negative 2. When x equals 2, f of x is equal to negative 1. And when we have x equals 8, 2, 3, 4, 5, 6, 7, 8, x equals 0. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now in this case here, because of the horizontal shift, our vertical asymptote has now shifted to x equal negative 1. So we would have a rough sketch of that. Okay, in our last example, we have f of x is equal to log base a half x plus 3 plus 2. All right, so we're going to do the same thing we did in the last problem. We're going to focus on this x plus 3 and what we need that to equal to get some nice values to work with. Well, again, 1 is always a good value for that x plus 3 to equal, so we're going to set x plus 3 equal to 1, and if we solve for x, we get x equals negative 2. All right, so negative 2 is going to be the first x value to use. All right, so again, when we have a fractional exponent, we want to look at the denominator, and we want to use powers of 2. So 2 is a power of 2 to the first power, so if we set x plus 3 equal to 2 and solve for x, we get x equal negative 1. And again, powers of 2, let's do 4. So if we let x plus 3 equal to 4, we're going to get x equal 1. Okay? So we're going to use negative 1 as an x value and also positive 1. All right, so let's figure out what this equals. So if we plug in negative 2 into x plus 3, we would get log base a half of 1. And so log base half of 1 is 0. 0 plus 2 is 2. If we plug in negative 1, we get log base half. Negative 1 plus 3 is 2. So log base half of 2, so 1 half to the negative 1 power would equal 2. So that the logarithm would be negative 1. So negative 1 plus 2 on the outside equals 1. All right, same thing with x equal 1. If we plug it in, we get log base a half of 4. Well, 1 half to the negative 2 power is equal to 4. So we get negative 2 plus 2, which is 0. So we have our 3 points. So negative 2, 2, negative 1, 1, and 1, 0. The vertical asymptote is now at x equal negative 3, so this graph is hugging negative 3, and then we have a decreasing function. All right, so that is some examples of graphing logarithms by hand without using a graphing calculator. I hope you liked the video. Please like and subscribe, and I'll try to get more content out there. Thanks for watching.